All right, class, I want to talk about air pressure today. Okay, air pressure, of course, is the pressure of air squeezing down on us. Okay, we have a big atmosphere above us, and gravity pulls it down, so there is a pressure on us. Okay, we call that, around sea level, that's called 1 atmosphere of pressure. Okay, so that means converts to in pounds per square inch, which we can understand. It's about 14.7 pounds per square inch on your body. So you don't really realize it because it's equilibrated all around you, but you do notice it if you go up in the mountains where there's less air above you, so there's less air pressure. It gets a little bit thinner up there, so you feel that. Your ears kind of pop a little bit, okay, and a little uncomfortable. You definitely feel it when you go underwater. Now, underwater, you're not under air pressure, but you have the air above the water, then water's heavier, so you can get more pressure there. So that actually, about every 32 feet, this doubles. Okay, so 2 atmospheric pressures when you go down there, so you can feel that pressure. Okay, but what I'm trying to demonstrate to you today is the effect of that pressure. Okay? You may have seen this little demonstration before. So if you take this a jar, something like this, fill it all the way to the top with water, which I've done. You just take an index card like this, place it on top, okay. Then flip it over. Of course, hold it there so nothing comes out, but if I let go of it, okay, nothing comes out. Okay, the water's pushing down, but air pressure is enough to force it back up. Remember, 14.7 pounds per square inch. Okay. So that keeps that on there. Now here, I'm going to demonstrate another little demonstration. So I've got hot water here, which I'm going to place into a Coke can, just a little bit. I'll do it with 2 just to do the experiment twice. Okay. So I've let these cans heat up a little bit. You can see there's steam coming out. So what I've tried to create here is a can with water in there, and then bring it to a boil. And if it's a vigorous boil, that should drive all the air out. And so now I'm just left with steam in those cans. Okay? And then once I invert it over, flip it upside down into the ice cold water here. Hopefully that steam, which is in a vaporous state, will condense, leaving the can empty of anything. Okay? Air's all been driven out, you just have water vapor. Condense the water vapor, you should have nothing, which is a vacuum. So let's give it a go here. Okay. 1, 2, 3. Now watch what happens when I lift up. A lot of water comes up. Try this one. 1, 2, 3. You can see it collapses pretty good. Okay. So again, that's that air pressure forcing down. Okay. But before they collapse, there's still the same amount of pressure pushing out. But when I took all that air out of there, bingo.